very slowly, but this initial velocity is neglectable.
And it's also it's always constant if you put it this way.
Well, actually, if you this is at the same low range, this initial velocity from your finger if you try to tilt the domino stone.
Okay. So it's negligible. Okay.
Yeah, of course. If you
that's
push the domino stone this way, this okay, it will fall of course fast.
Can you shortly sum up your energy transfer as you explained us in the slide? It's very complicated. Just very short.
Okay, well, actually, just very short. Okay, with of course the impact through a graphic or formula. What do you like?
Just a graphic.
Okay, one graphic. Okay, we have here an array of dominoes. Here, domino stone.
Just for 2 dominoes.
Just you have also to consider the array of dominoes because we have here also a velocity and this impacts.
Yeah, but for the starting of the chain reaction, just the first 2 dominoes are relevant. I don't think
actually the first they are just the first 2 dominoes.
Yeah.
Actually, the next if we have the third domino stone, these 2 stones have also an influence.
Yeah, but if the first dominoes don't fall, the chain reaction will happen.
One action with here center of gravity.
Yes.
So this has to be lifted over the vertical. So that it has to be lifted.
Yeah, but you don't have a proof here that that's right.
Well, actually, what you can do is it works or it doesn't work.
Yeah, but there's the block, it works or it doesn't work.
Actually, see, with here smaller dominoes, when we try to flatten the surfaces, we have a different factor of increase, and we try to decrease this factor, so decrease their size, so that it don't work. So actually, we have here different increases in this factor.
Okay. Well, I'll sum up the opposition. I think you did a bit too many simplifications for your theoretical model.
Actually, I think it's okay because I have increased the ground friction and also all the other friction.
And also you had a bit less measurements you showed us in your presentation because
drive this you will then have velocity.
Okay, and this is a question for both the reporter and the opponent. Is the angular momentum conserved during the collision time?
I think so.
It is conserved?
Yes.
I don't think so.
And then also a question for also here is a question for both the opponent and reporter. What is the collision type between the domino?
I think it's a partial elastic collision.
Partially elastic?
Yes.
I think that it's an elastic collision and it impacts and then we have and then they are in contact with each other. And then we have frictional process.
And you think it is elastic or inelastic? Inelastic? Elastic. Okay. Okay. And what do you think is the function for the size limitation? What will be the variable that determines the size limitation between the domino?
I can draw it on the blackboard.
You have short answers, please.
Yeah, well, actually, you have to introduce a scaling factor, and from height times scaling factor, 1 times scaling factor, thickness times scaling factor. Then, if you can solve this, then get your scaling factor.
I think there are the relevant parameters, this ratio between the thickness and the height of this domino, also the distance between the dominoes and the factor if you have, and the mass of your domino, which you get over the density.
Okay, thank you.
No more questions? No, then let's start the time for preparation.
Okay, good morning ladies and gentlemen. I will start the review on the excellent discussion that went between the team of Austria and the Germany. So, first I have the reinforcements for both the presentation and the opposition. So first the presentation. They needed a steadier pace for explaining the fundamental theories and they had to discuss more with the opponent about it. And they needed better explanation of the governing equations for the Lagrangian justifiability. And then for the refutation, they needed to have more focus on the experimental and the validity of the data. And here's the classes that I was able to find during the discussion. First class is about the experiment. The opponent asked, why did you push it by hand? Wouldn't this give more energy? And this was a really good point. And the reporter pushed very slightly, and I think there needed more improvement in that answer. And then the opponent team asked, are there differences in the height limitation for cases with friction, friction and without friction? And the reporter answered, values changes if you include friction. The range is about 1.2 to 1.5. And then the last clash is about the theory. The opponent asks, how is this elastic collision? And the reporter did not give a strong answer. And then the opponent team asked, does the center of the rotation changes? And the reporter said, the center stays the same. And then the opponent team asked, could you consider it types of increasing vectors? And the reporter gave a really good answer. So the crux of this clash is that the role of heating should be clarified by the reporter side. And then I would like to talk about some of the missed points that I was able to find during the discussion. The missed point which I was not able to find neither in the presentation nor in the discussion. So first missed point is that the missed objective. They had to focus more on the size limitation and about the question, what is amplified? What is the physical value that is being amplified? Because the question's name is dominant amplified. And then about the Lagrangian justifiability, the team of Austria had to give more explanation on the friction term and the energy loss and the collision between the dominoes, which had to be considered when using the Lagrangian theory. And then about the missed torque, the torque that was caused between the dominoes was not considered nor in the discussion, neither in the presentation. And about the energy transfer among the important types of energy, many types of energy was not considered in the presentation during the discussion. Next. And about the angular momentum, and since the change in angular momentum is dependent on the collision time, so there had to be more investigation on how long is the collision time, because that would change the amount of the change of the angular momentum. And also about the bouncing back motion, since the Austrian team has mentioned that the collision will be elastic, if it is elastic, there might be a bouncing back motion of the domino. So if that bounces back and there will be multiple collision between the dominoes, which will change the whole process of energy transfer. And also about the detachment, if the last domino is faster than the previous domino, there might be a detachment happening, and that will change the energy transfer process. That was not investigated in the presentation nor in the discussion. And about the missed experiment, many variables was not mentioned, and the measuring method was not clear. And so overall impression, there needed validity of the theoretical model, and in the experiment, more actual data and more explanation on the validity of the data was needed in the discussion and the presentation. Thank you very much.
Thank you.